All right, thank you guys for coming to AzureConf today. Before we get started, I just want to take a few minutes to remind you of the Global Windows Azure Bootcamp that is going on Saturday, April 27th. There's over 100 of these sessions going on all over the world. Definitely encourage you to check out globalwindowsazure.azurewebsites.net. Find a location near you, go ahead and follow the links to register, and get set for a pretty fun-filled day of working with Windows Azure. This is the Taking Control of Your Windows Azure Services presentation here at AzureConf. My name is Michael Collier. I'm a cloud architect and a Windows Azure MVP. If you want to get a hold of me, you can follow me on Twitter at Michael Collier or on my blog at michaelscollier.com. It's pretty much a Windows Azure focused blog. Today we're going to be talking about some different ways we can work with the Windows Azure Service Management API to really have more control on our various Windows Azure services. And there's a lot of different ways we can manage our various Windows Azure services. One thing most people are probably pretty familiar with is working with the Windows Azure Management Portal. I can certainly do a lot of stuff in there. I also have the CLI tools that I can work with on multiple different platforms. We have the Windows Azure PowerShell commandlets that can be a great way to kind of chain a series of events together, creating new virtual machines, cloud services, storage accounts, stuff like that. Really powerful set of tools there. We also do a lot of management operations from Visual Studio itself, working with storage accounts, virtual machines, and cloud services there. There's also some really nice tools available from partners like Cerebrata in their Azure Management Studio that allow us to work with our different cloud services and storage accounts in a pretty nice way. All these different tools pretty much have one thing in common, that they leverage the Windows Azure Service Management API. If I was to put Fiddler on my machine and run that and use the PowerShell commandlets, for example, to get back a list of cloud services, I could see the PowerShell commandlets making calls out to the Service Management API. But sometimes we need a little bit more stuff to work with. We need a little bit more control on our applications. And this could be maybe just developing our own custom management tool. Right now, the Windows Azure tooling doesn't really have a concept of role-based security for us to kind of differentiate different users in our organization and the things that they can do with Windows Azure. So maybe I need to create a tool that brings in some of my own identity management and own rules from my organization to allow the users to do certain things. Only certain users can take certain actions against Windows Azure. It can build into a custom workflow, so I kind of chain a series of events together, sending emails, tapping into other systems if I need to do that. You can also use the Management API to go ahead and adjust or create services in a more programmatic manner. And a typical example of this is a multi-tenant solution where you have to go in and every time a new user comes on board, maybe I need to spin up a new cloud service, change the number of instances that I'm running, create a new storage account, create a SQL database, any number of operations there. I need to kind of programmatically add different features to my Windows Azure service. A common example is also just the scale factor within Windows Azure. I need to scale up or scale down the number of instances that I have based on the load that our system is under at the time. And maybe it's not just a matter of scaling a number of instances in a web or worker role, but it could actually be more taking on the concept of a scale unit, where I need to go through and, in addition to adding a new cloud service instance, I need to add a SQL database and a storage account as well. So I kind of chain a series of events together there. All these things use the Service Management API. The Service Management API is the native REST-based API for working with Windows Azure at a management level. Like we said, PowerShell uses it, Visual Studio uses it. We can certainly use it as well to kind of customize and create our own processes. We can do a lot of different things with the Service Management API, working with virtual machines, Windows Azure Traffic Manager. I can get a list of all the different Windows Azure data center locations that are available, storage accounts. I can see information about my subscription, and I can work with hosted services or cloud services as well. One of the things you'll notice when working with the Management API and cloud services is that everything is still referred to as a hosted service, which is kind of the older name, the original name for web and worker roles. The API still refers to them as a hosted service. And when you're working with virtual machines in the API, you'll also work with hosted services as well, because a virtual machine is really just another type of a hosted service role that we're working with. When you go ahead and get started using the Management API, you should know there's no library built into the Windows Azure SDK. Like there's a storage client library for working with storage. There's no library by default for working with the Service Management API. We'll see some stuff coming on a little bit later that makes working with this a little bit easier to work with. It is a REST-based API, so I can get to it from pretty much anywhere. I can send HTTP GET or POST operations to the API to do what I need actions to be carried out. And then I have to be pretty comfortable in working with XML using this API. Every time I get operations back or get some data back from the service management API, I'm getting back an XML document, and it can be a fairly large XML document. So I need to be comfortable pretty much parsing that document. If I want to create new things, I need to be able to build up an XML document and send that as well. To get started, I would recommend checking out the MSDN article we see here on the screen. It has a lot of good information on all the different operations that you can take advantage of with the Service Management API. Lots of good details there on what the request response should look like, some nice code samples as well. But I would point out that sometimes the documentation on MSDN can be either slightly out of date or just have some inaccuracies with it. So when you're working with it, be sure that you're capturing your responses that come back, the XML you get back, and understanding certain elements may or may not be there, or maybe named slightly differently than what MSDN expects. So just do some pretty good testing on that to make sure you're getting and be able to parse the XML that you're expecting. To go ahead and get started, we also need to authorize ourselves with the Service Management API. And if we worked with PowerShell or Visual Studio before, you know they have to put a management certificate in place. This management certificate can be obtained via published settings file, which you can get created by Visual Studio or PowerShell. The CLI tools can help you get that published settings file. Or you can go a manual route and create one using a tool called MakeCert. That's typically the way I go. I like to have a little more control on my management cert, so I'll use MakeCert to create my management certificate. I'll put this management certificate in my local certificate store, and then I'll also take that certificate and upload that to Windows Azure certificate store as well. So I go into the settings section, go to the management certificates, and upload that management cert there. That'll allow me to be authenticated and authorized to work with the Service Management API. There are different versions of the API available out there. There's several different versions. You can find the complete list out on MSDN. But we set the version we want to work with using the XMS version request header on all of our requests. The latest version is the 2012-0801 version. Although some MSDN pages will say that that's not the latest version, that there is a 2012-0301 version. That's the latest. So when you're working with the API, go out to the MSDN page that shows you the list of all the versions. Make sure you understand what the latest version is, because sometimes that documentation can be a little bit out of date. To go ahead and get started sending this information over, we need to go ahead and get our management certificate. So you see here a little code snippet on getting our X509 cert using our thumbprint. We're just going to pull that out from our local certificate store. I attach that certificate then to a request handler and its client certificates collection, passing that handler now that I have with the certificate to a new HTTP client object, and then I can pass in on the request headers the XMS version header and the version number of the API that I want to work with. So pretty easy there. It's just, you can see a couple lines of code to go ahead and get started getting your management certificate in place, as well as getting your API version down. There's two types of requests when it comes to working with the Service Management API. There's synchronous requests and asynchronous requests. Synchronous requests are typically what we would use on any sort of GET operation. I just want to get a list of services, get a list of storage accounts. Asynchronous request, it's typically going to be some sort of create or update operation against the API, where I'm going to send some data to the API, and then I'm going to have to kind of pull for completion on that. Let's take a look at this in a little bit more detail here. So you can see I have here my client object and the Windows Azure Management API. I can issue an HTTP GET request to the Management API. In this case, I want to get a list of all the different cloud services. Notice again that it's hosted services with the API. And then I need to, when I get that response back, I get a list of different hosted service elements in this XML document. And I have to go through then and parse that to make it work like I need to. I will also get back an XMS request ID. For these synchronous type of operations, there's really nothing we need to do with this request ID. It's really provided for us so that we can look at the Windows Azure operation logs in the portal and kind of see some of the details that might be going on if we want to correlate some of the logs together with certain actions that we're taking. Like I said, asynchronous requests are generally for any sort of get or update operations, or excuse me, any sort of create or update operations against the API, creating new cloud services, creating a new deployment, that sort of stuff. So in this case here, I'm going to issue a post operation to the Management API, where I want to go ahead and pass a payload over that's going to create a new cloud storage service for me, a new storage account. So in this case, we're going to create a new Collier service account, storage account. I'll get back an HTTP 202 accepted, as long as my request was well formatted, the Service Management API accepted that request, and I'll get back as XMS request ID. I could then use this request ID to go ahead and query the management API for any sort of updates, kind of asking, am I done yet for this certain operation? I'll get back then an operation response that tells me whether that request is succeeded, failed, or if it's still in process. If it's still in process, I can go ahead and maybe can put a while loop in place where I check every 5 minutes, for example, or 5 seconds, for example, to make sure, see if we've succeeded or failed with that operation. So let's take a look here at working with some of the basics of the Service Management API. So we'll switch over to Visual Studio. We're going to pull up a little bit of code here, a console application. So we can see here we've specified some constants. We're going to have a service name, AzureConf Web. We got our subscription ID and our management certificate thumbprint in place. All we're going to do here is I want to go ahead and get my subscription information. I also want to list some different cloud services, list out all the cloud services I have. I want to go ahead and create a new cloud service, and then I'm going to deploy to that cloud service as well. So if we kind of walk through some of this code a little bit, see on our do get subscription here, we're going to call a subscription operation class. We'll see that here in a second. Say get subscription on that, and then I'll get back an X document here as a result from the API, and I can go ahead and parse that. So to work with this, what I did is I created a portable class library, and we'll see why I created a portable class library here coming up. But this library, if we go and look at Visual Studio here, basically just a bunch of helper methods to allow us to work with the management API a little bit easier. We have our model folder here, and it defines things like a role, gives us some role properties. We have role instances as well, some things that a role instance would have. If I want to look at a subscription, I see some of the different properties that a subscription might have as well. So this makes it very easy for us as we parse out the XML to put it in some sort of entity class or model class to work with a little bit nicer way. If we look here at if we go back to our code here, we look at the subscription operation. See subscription operation here. It has just some things we can work with against subscriptions. And we'll have different operations for working with like storage accounts or cloud services as well. So to get a list of subscription or get my subscription information back, I basically have to issue a request to this URI here, management.core.windows.net, passing in the subscription ID. And then I'm simply going to invoke that URI. If we take a look here at our invoke operation, we'll go to our service management operation class. And we have two different versions of the service management operation, which is why there's an interface for it here. And we'll see why there's two different versions coming up. But basically, this is kind of the basic class that I have for working with GET and POST requests on the management API. I have a little bit of code here to help me get a particular X509 cert from my local certificate store. And then my invoke operation is just with some of the code we saw before, where I'm getting a certificate, attaching it to the request, and putting the request header in place. And then I'm simply just going to do an asynchronous GET request using HTTP client to send that request off to the management API. I then get that response back, turn it into an X document, and return that. If I want to do a POST operation, it'd be very similar, except all I'm going to do here now, all the same stuff with working with our certificate and our management API version header, but now I send in an X document that is the body, the payload for our request. Turn that into a string and get the bytes for that, and then I use this little bit of code here to do an asynchronous POST request, streaming that information up to the API endpoint there. Make sure that I'm specifying the content header there as well, and then we're going to get back our XMS request ID that we can use to pull the management API to see if there's any updates available. So we'll walk through that, getting a list of subscriptions. If I wanted to, the next thing is getting a list of cloud services. So we can take a look at that. We have a cloud service operation class that has a list services method on it. So let's look at that. So we'll go to implementation here. Let's move this over a little bit. We see that all we have to do to get a list of services is, again, we're just building out the URI that we're working with, So we can get all these URI formats from the MSDN. In this case here, list services is simply just calling management.core.windows.net with our subscription ID and then asking it to get a list back of hosted services. Then we simply invoke that operation, which we know gives us back an X document to work with. So pretty easy there. If I wanted to create a new cloud service, this is where I have to do a little bit more operations because I'm actually having to do a post now to do that. So I specify some various information here like a label and description and where I want this new cloud service to be created. And then I can go in and look at my create service method. And create service for us is simply going to do the same thing, formatting the URI that we get from MSDN, and then I have to create a new service payload. It's basically building out the XML document that we need to send. So in this case here, all we're doing is just simply using X document and X element to build out the required parameters for creating a new cloud service. And the order is important on this, so MSDN will kind of list out the order and remind you that the order of the elements is important, so it's something else just to keep in mind there. We get that payload back, and then I can simply invoke that operation doing an HTTP post, get back my request ID, and then I have to use this request ID to go ahead and continually pull for completion. So I have that request ID here, and now I can just say, hey, give me the request, give me the status for this operation. If that status is succeeded, then I go ahead and get out of this loop, and we know we're done. So that creates our cloud service. If I wanted to deploy a cloud service, something very, very similar, I have to upload my package file here to Windows Azure Blob Storage. If I was kind of making this a little bit more robust, I'd probably have some code using the storage client library to go ahead and do that for me. But for the purposes of this demo, we've gone ahead and uploaded that. Then I have my configuration file, the path to my configuration file that we're working with. Give it a deployment name. I need to read in that configuration file. And I'm going to pass that to this create deployment method on our cloud service operation class. So we can jump into that. You can see it looks pretty similar to creating a new cloud service, but we have a new method here, create deployment payload. Create deployment payload is all just going to build up an XML document that we pass in that's going to have the required parameters, again, order matters, for our creating a new cloud service. And we're going to convert that configuration file we read in, we're going to convert that to a base64 encoded string and add that as well. Then we're going to invoke that operation and get back the request ID. And then we can do the same type of thing, just put a while true loop in here, go ahead and asking the Service Management API if it's done yet. And remember, working with cloud services, we might get a response back pretty quickly that says that this deployment has been created, but it could take several minutes for those actual cloud service instances to be fully deployed. So let's go ahead and walk through this just to kind of see some of this code in action. So we get our cloud service or subscription information here, get back the result. If I was to look at this result, we can see here in the visualizer and kind of just see some of the basic information that we get back about our Windows Azure subscription, the email IDs, number of cores, and virtual networks, and all the stuff we're allowed to have there. So go ahead and continue on with this. We can parse that subscription information out to give us an object that makes it a little bit easier to work with if we wanted. And then we can keep on going, going to list out the different cloud services we have, doing the same thing, right? Call that API. And then I can get that list of hosted services here. You see now I have a list of hosted services, and this includes all my web and worker roles, as well as any virtual machines that I have deployed. So if I wanted to print this list out, I get a list of the different hosted services and iterate through that. Continue on with this. Now I can go ahead and create a new cloud service. I should get back a request ID here that says that the management API has at least accepted our request, and we did. And now I can ask to see if it's done yet. And it succeeded pretty quickly in creating that new cloud service, which is good. And I can go in and try to deploy this cloud service now. So keep walking through this, read in our configuration file, go ahead and create a new deployment, again building up that XML body and posting that to the API. We should then get back a request ID. And we can use this request ID to go ahead and query for any updates. So we have a request ID here. And we should probably see one of the first things that it'll be in progress. This will take a little bit of time for this one to finish. So we'll go ahead and run this one. Now let's jump over to the management portal a little bit, and let's refresh this to try to get that new cloud service we just created to show up in the portal. All right, and in the management API, we got the response back, so let's just go ahead and finish this. So we did get a succeeded operation back from the API. We go back here to the portal, we can look at this. When it finishes loading, we should be able to see that new AzureConf web service created, as well as those instances should be spinning up. Again, that'll take several minutes for those instances to spin up. One of the things you'll notice with the portal is it does sometimes these various pieces take a little bit of a while to load. And then once you start working with the API a little bit, you kind of see and understand why not everything comes back right away. Like why virtual machines seems to take a little bit longer. We'll see that. Working with storage accounts and some of the other stuff does seem to take a little bit longer for them to come back. And you kind of see that this management portal is actually using all the same stuff that we were just using the service management API. So there could be a lot of back and forth traffic to get that information. So we see here is our AzureConf web project that we just created, our new cloud service. We can look at the instances on this. We can see that we're now starting up those virtual machines. So even though we got a succeeded operation back, the service has been created, the machines aren't fully up and operational yet. So if we wanted to kind of put some more logic in here, we could query for the status of these virtual machines and then wait for those to be fully running instead of in process. So the console there that we saw is pretty nice, and it gives us some ability to go ahead and list cloud services and list subscription information and deploy new cloud services. It's really not that visually exciting. What I wanted to do was to create a Windows Store application. It really was a way to kind of give me a chance to work with creating Windows Store apps. So let's take a look at that a little bit, and then we'll walk through some of that code. With this Windows Store application, I can see here I made it call out to my subscription details where I could get a list of everything that's going on and print that out on the screen. And then I have this very crude, don't make too much fun of me yet, for my Windows Store design skills, but I can work with storage accounts, cloud services, and virtual machines from here. So if I look at my cloud services, I can kind of see a list here of all the different cloud services that I created in here, including the one we just created. I can go back and I can work with my different storage accounts that I have, get a list of these different storage accounts. Maybe I want to create a storage account as well. So I'll say add there, and I can check to see if the storage account is available. So we'll say MC AzureConf1, see if this is available. And sure enough, I have a little bit of a layout problem with my UI, so I need to adjust that a little bit later. But we'll go ahead and create this storage account as well. Submit that off. This will again take a couple seconds for that to come back. The green button should light back up again, or we can go back to the Windows Azure Management Portal and see this AzureConf storage account being created. So we'll go back here and see if we can see it. Here it still hasn't shown up yet, so we'll go back into our portal and take a look there. See if we see it there. We'll refresh that and maybe come back to that in just a little bit as well. So let's look at some of the code for this. We'll stop this application from running. And we saw working with a storage account. So we go and look here at our storage or service management library. We can look at our storage account operation class. We see some information in here where I got a method that basically checks the availability, which is the method we called from our Windows Store application. Basically, it's doing a GET request to get back a document that says whether that's available or not. I can just parse that response back out. If I wanted to create a new service account or new storage account, I just build up an XML document here and post that and get that request ID that says that's been done. So working with our storage account, working with a Windows Store application, there's a couple of things we need to do as well. So I'm going to go ahead in here and I'm going to look at my app XAML here, and I need to specify my subscription ID. So I'm going to put that into my app XAML file right here, so I can reference that from any of my pages. And I also need to load up a Windows Azure Management Certificate. So to do that, I have my onLaunched method here in the code behind, and I have this load Windows Azure Management Certificate method. This has a little bit of code that is basically going to get our management certificate from a certificates folder. So this purposes of this example, we're including our management cert with our application. And then I have to add this to basically the sandbox that Windows Store applications run in. And that's the code we have right here, where I'm using the Certificate Enrollment Manager to import that PFX file. Once that's done, if I wanted to go and look and see that certificate, I could find it under my user profile, going down into the path for this particular package that we've just deployed, this Windows Store application. So we have the management cert. I need to attach that to my request. And this is a little bit different than what we saw when working with the console application, because I have to attach that cert a little bit different way. Basically, the biggest difference is with the HTTP client handler. I just set the certificate or the client certificate options here to be automatic. And then it'll pick up that certificate for us. The rest of the code is pretty much the same as what we saw in working with our console application. Now, I want to show you something with virtual machines because they're a little bit different to work with. So we'll go back into our cloud service operation class here, and I want to list out the virtual machines. So you notice with listing a virtual machine, they're all just cloud services or hosted services according to the API. There's no way to get a list of just virtual machines. So if I say list services here, I'm going to get back a list of all the different hosted services that I have, and now I have to iterate through each of those hosted services, getting the service name, and then I want to go ahead and get the deployment and the production slot for that particular service. This is going to give me back a document here that I can parse into working with a deployment object that I have. And now I need to look at that deployment object, find all the roles for that particular deployment. I'm looking for then a role that is a persistent VM role. This is not the other VM role. That's the stateless VM role. These are the persistent VM roles, are virtual machines. So once I have that collection of the different cloud services that have a persistent VM role type in them, I can then simply do a simple query here and return out a list of all those hosted services that are persistent VM role type of services. So pretty easy to work with there. It's a little bit kind of convoluted, a lot back and forth, which is why when you want to list cloud or virtual machines in the portal or using this Windows Store application I created, it can take a little bit more time. I want to talk now a little bit about how we scale our solutions. And Windows Azure is a scale-out model, so I need more instances of a particular virtual machine. So I can scale from 2 instances to 3 instances or 4 instances, and all of our scale options are controlled at the role level in the service configuration file. So to scale the number of instances we have, I have to go ahead and get a deployment and get its configuration file, and then edit that configuration file to have the number of instances that we're working with. So let's jump in here to our application and look at how we go ahead and update a particular cloud service. So I'm going to look at our pages here for cloud service details. We'll look at the code, then I'll run the application here. So I have a button on this page that is going to be increase the count for this particular cloud service so I can increment or decrement the number of instances that I have. So we have a little bit of code here that's going to go ahead and get our deployment from a collection of deployments we have. Then I'm going to go ahead and find that role for that deployment. And then I need to call these methods here to get an instance count and set the instance count. So we'll take a look at these. Getting the instance count is basically just an exercise in parsing XML where I need to find that particular role element in our configuration. And then I need to go ahead and find the instances element and then update and then return the count attribute as well. If I wanted to change that, it's very, very similar. Finding our role element and then going ahead and updating that count attribute on the instances element. From there, I can call this change deployment configuration method that we have. And this is going to go ahead and build out an XML document for us. That's going to be the payload that we're going to post to the Service Management API. I will encode our configuration file as a base64 encoded string, and then I will simply invoke that operation, getting back the request ID, and I can continually pull on that as well. So if we take a look at this in our Windows Store application, go here and let's work with cloud services. And AzureConf Web is one that we created earlier. I can drill into that and I can see if I have production or staging. I don't have a staging deployment for this one, only production. So I can go ahead and select a particular role and then say increase instance count on that. And this will take a few minutes for that to actually go ahead and actually spin up those other instances. But we can instead, we go back and look at the management portal for our cloud services and AzureConf Web. We should see that this is now transitioning and we're adding in another instance to our cloud services here. So we're spinning up one more instance of this particular cloud service. So pretty easy to work with, just a little bit of back and forth on getting the configuration and comfort level needs to be obtained in parsing out XML, but overall not too bad. So as we just saw, it's pretty easy to go ahead and get the properties for a particular service. I have to get the properties because a regular getting list of cloud services doesn't show me everything. I need all the deployment and configuration information. So once I have those properties, I can get the deployment, get the configuration element, decode that into a string I can work with, update the count attribute, re-encode that XML configuration, and post that back to the Service Management API. Some tips in working with the Service Management API, get your basic get and post operations down first, where you can set the API versioning, the content type, the request ID, get all that in place first, because after that it's really just an exercise in parsing XML. It's not a difficult API to work with, but there is a certain level of comfort that if you're not used to it, you just have to get comfortable in working with Xdocument and Xelement, which can be a little bit of a tedious operation, but it's not too bad. We'll see a better way here that we can actually work with the Service Management API. It makes so we don't have to write quite as much code in XML parsing. So when you get these slides, you look at these online. A little bit later, there's a couple of blog posts I want to point out here. One by Azure MVP Gaurav Mantri, who has a really nice post on working with the Service Management API in a Windows Store application. Definitely pay attention to his special considerations section, where he outlines a couple of things you have to do to your management cert when working with a Windows Store application. It'll save you a lot of time there. Neil McKinsey is another Azure MVP. He has a great book, the Microsoft Windows Azure Development Cookbook, where he has a section in there on working with the Service Management API and some great code samples. And of course, we have MSDN as well. I said there's a better way or an easier way to work with the Azure Management API, and that's through a library called Azure Fluent Management. This is a library written by two Windows Azure MVPs, Richard Conway and Andy Cross. It's available out on GitHub. You can get it at github.com/AzureCoder, or you can see some really nice examples on his GitHub repository as well, and also at fluentmanagement.elasticcloud.com. Some really nice examples and kind of an explanation on how this library works. This library is really more than just a simple wrapper around the API, although we can certainly use it like that. We have some nice classes to work with to make working with the Service Management API a little bit easier, like cloud services and subscription and storage account, that kind of give us that nice entity or model to work with. But it becomes really easy for us as a C# developer to go ahead and write, basically you see here just a couple lines of code, to go ahead and get a list of all the different cloud services we have. So I create a new subscription manager, passing in my subscription ID, work with the published settings extractor to get a management cert, and then I just say subscription manager.getDeploymentManager, adding that management cert. I'm going to create a query to list out all the different hosted services. And with the Azure Fluent Management Library, I can work with SQL databases, the different deployments I have, creating new virtual machines, working with cloud services, and so forth. So there's a lot of stuff I can do with this library. I think one of the really attractive options of the library, though, is its ability to have a workflow, and really a transactional-based workflow. So if I need to create a new cloud service, a storage account, and a SQL database all together, there's a chance that one of those could fail. Maybe I've reached a limit on the number of storage accounts that I could have, or I put a bad name in for a particular cloud service. What I want to do is have those all complete together, or I want them to all roll back if one of them fails. And that's what I can do here in this code sample, where I go ahead and list out the operations I want done, and then put them as steps in this service orchestrator. And what will happen, though, is since the Management API doesn't really have a concept of transactions, it'll basically, this library will issue compensating actions to undo or unwind the series of steps that we need to get us back to our original state. So that's a pretty cool feature of this library as well. To install it, I can use NuGet, go ahead and install a package using elasticcloud.azuremanagement.fluent, or if I'm using the package manager in Visual Studio, I can search for it there and I can see some of the other dependencies that this library has as well. So let's take a quick example, look at creating some code here with the Azure Fluent Management Library. Go back in here to Visual Studio. Let's stop debugging on what we had before, and let's go ahead and create a new console application. Create a new console app. Let's call this Fluent Console. Now I need to go ahead and install that NuGet package. So we'll get in here to our package manager console, say install package Elasta Cloud Azure Management.Fluent. Go ahead and install that guy. So it's going to pull down all those different dependencies from NuGet and get our console application. Whoops. I think I told it to use the wrong one, so we'll have to stop that and add that in again a little bit later here. Wait for that to error out on me. In the meantime, let's go ahead and add some of the code we know we're going to have to add into this. So I've got some snippets in here that I can work with to make this a little bit easier. There we go. So that's failed. I need to actually change my project here. Let's try this again. There we go. I've seen those errors before. They don't seem to actually be impacting anything, so we're going to skip over those. Now let's add a couple of snippets in here to make working with this a little bit easier. Fluent management, I need to list out my credentials, so I need to have my subscription ID and my management certificate thumbprint. Now I need to go ahead and create my subscription manager. So go ahead and add that, my subscription manager, and then I publish the settings so I can get that management certificate. And now let's go ahead and do some things like listing out the different cloud services that I have. So maybe I just want to list the different cloud services. Again, very easy. We saw some of this code before in the PowerPoint slides. I can do stuff like maybe I want to get a list of all the production deployments as well. So I'll say Azure here, and let's go ahead and do that. So I can say, I just want to go ahead and get me a list of all the different hosted services that have production deployments. So pretty easy, pretty simple code to write there. Maybe I want to find a particular cloud service. There's some nice querying capabilities as well. So we'll say find service, and I want to call this one AzureConf-web. Let's go ahead and create this guy here. And let's add a little bit of code to this. I want to find that subscription, or find that particular cloud service. So we need to rename this to service name. So now we can see here we have a very nice link query that we set up to say work with our particular subscription and management cert, and then just basically go ahead and query the service management API, finding a particular cloud service that we're interested in. So pretty easy to work with there. I can also create a new SQL database, which I think is pretty slick. Let's say create SQL DB, and I want to call this one my AzureConf DB 202. Let's go ahead and create that method, and let's add in some of this code. Again, we'll use some snippets here to help out. So we need this to be database name. So you can see here, what we're doing is using the new SQL manager instead of a deployment manager. We have a SQL manager where I can add a new server to the Eastern US data center, work with my certificate. I can add the firewall rules, so allow me to have access to that, setting up my storage credentials as well. All that in one line of code. Very nice, easy to use, fluent syntax as well. So hopefully you can see from some of this code, this library makes it a lot easier to work with the service management API. We could do all this stuff ourselves as well, writing out a bunch of XML, but this really simplifies the logic we have to write for us here. And just to quickly recap what we saw, we created a new console application to work with. We installed the package via NuGet. I already had a management cert, so I didn't have to create one, but if I needed to, I could create a new management cert. I create a new subscription manager instance that allows me to work with all the things in that particular subscription. And then I can just simply start using the very nice Fluent API to go ahead and query the service or to create new cloud services or SQL databases, that sort of stuff. One of the things that comes up a lot in working with Windows Azure is people want to talk about scaling their solutions, and particularly automatically scaling them. And right now, there's really nothing in the Windows Azure platform that does that for us automatically. There's some third-party services like Azure Watch that we can use, that we can pay them to monitor certain metrics for us and make scale decisions. That works pretty well. or I could certainly write it myself. I could write a lot of code using the Service Management API, parsing out the XML and manipulating a lot of stuff there. There's a lot of extra code, though, you have to write, and I kind of would question sometimes what value you'd be providing that you couldn't get out of something like Azure Watch or another service. People say, well, how hard could scaling be? And initially, it's, hey, I just want you to get more instances when I'm busy, and then scale down the number of instances when I'm not busy. It seems pretty easy. What's so hard about that? But when you start thinking about it, there's a lot of different things to consider when building out a scaling solution. What is busy? Is it CPU utilization? Is it number of items in a queue? What is that number of items in the queue? Is it number of records in a SQL database table? Lots of different things that can constitute busy. And then is that a predictable period of busy? Is it weeknights, weekdays, weekends? What's busy? Can I predict that load? And then maybe how do I scale based off those that knowledge I have? How fast should I scale up my solutions? If I'm scaling from 1 to 2 worker roles because a number of messages in a queue, maybe I want it to maybe try to give the system time to stabilize a little bit. So as I'm scaling up, I want to wait basically a cool down period before I start making other scale decisions. So I don't want to get a case where I'm scaling up and then I'm shutting down instances and then scaling back up and scaling back down again, kind of a thrashing going on. And then how do my scale decisions impact my overall cost? Do I want to just keep scaling, adding more and more instances, or do I want to kind of bound the system saying, hey, I want no less than 2 instances and no more than 15 instances available, putting a maximum ceiling in place so that basically would help me control my costs. I don't want to pay for that. Then maybe I also need to get a human involved to say, hey, why do we think we need to keep scaling above that limit? Or I need to make a configuration change. So a decision maybe is not to add more instances, but instead to make a configuration setting change to change some functionality of my site, maybe changing what users can do to kind of help offset some of the load that's going on. So as you can see, there's a lot of considerations to really take into account here, and it gets a lot harder, a lot quicker. We have to write a lot of code. Thankfully, the Patterns and Practices team at Microsoft has developed the Windows Azure Auto Scaling Application Block, or Wasabi, that makes creating a scaling solution really just a matter of configuration. We'll see some of the code and configuration for that. It's a really nice library that really simplifies a lot of those different considerations we just talked about. So it's the library that we can add to our Windows Azure projects. It's pretty much configuration driven. We really don't have to write any more than probably 3 or 4 lines of code to get this set up. And everything else is strictly configuration, which is fantastic. You're pretty much ready to go out of the box. If there are certain things of the API you don't like about Wasabi as far as how it scales or what actions it can take, you can certainly extend that to have your own custom actions as well. So that's pretty slick. And this is all part of the Enterprise Library Integration Pack for Windows Azure, which also includes the very popular Topaz library, or the Transient Fault Handling Application Block, which I pretty much consider a de facto standard on pretty much any Windows Azure project. We can host Wasabi in the application that we're wanting to scale. So if I wanted a web role there, I wanted to make some scaling decisions on that web role, I could certainly host the Wasabi Autoscaler in that role. The more common approach, though, is probably to have a dedicated scaler worker role, just a simple worker role that maybe we have, maybe it's an extra small instance, 2 instances of this extra small worker role, that its whole job in life is just to make scaling decisions for us. Or maybe I could host this on premises as well, maybe in a Windows service I have at my enterprise, and it can simply issue the API calls as well. To get started, I can use NuGet, install the Enterprise Library Windows Azure Auto Scaling package. If I want to use the package manager in Visual Studio, I search for Wasabi, and that'll find it as well. I would also encourage you to install the Enterprise Library Configuration extension in Visual Studio. There's a lot of configuration that you have to put in to Wasabi in your application XML file, your application configuration file. You can certainly write it yourself, but it does become a little bit tedious. There's quite a bit there, and you want to make sure you get it all right. This tool helps you with that, and it makes it a lot easier to work with. So in the configuration, how does this work? If we have a local Windows service, I'm going to have an instance of the Autoscaler, which basically is the class that does everything for me. I'm going to have my application configuration file. This configuration file tells the Autoscaler where to look for its various rules and some other configuration, storage accounts, that sort of stuff. I have a rules store XML file. This basically is a series of business rules to say when do I want to scale, what are the minimum maximums, under what conditions should I scale, and how much should I scale. And then I have a service information XML file. This file tells Wasabi what is my subscription information, what are the different cloud services that I'm working with, what are my different storage accounts, so that I can use kind of configuration information there to help drive those rules. And then of course I'm going to have my management certificate. The local service also is going to write to Windows Azure table storage. There's going to be two tables it's going to primarily use. There's an autoscaler data points table. That is basically a series of sample data that is using if I'm working for roles like monitoring queue depth. Maybe every 2 minutes, Wasabi is going to count the number of messages in a particular queue and write this to this table, and then Wasabi will use that information for its decisions. And then there's a logging table as well. I definitely encourage you to make sure your logging is enabled and working. Sometimes when you're setting up some of these XML files, you might have an error in them. Having the logging table available is going to be a great way to kind of figure out what's going on. Then that Windows service could issue service management API calls off to our cloud service. If I was going to have a worker role, I still would have much of the same stuff. I would have the autoscaler, the application configuration, and the management certificate would have to be in that worker role. I would also still use table storage for the data points and the logging. But I put all my rules into blob storage. So here maybe I'd create an autoscaler container, and I put my rules and service information XML files there. The nice part about this particular approach is that I can easily update these rules and service information files at runtime without having to redeploy my application, which is a fantastic way just to constantly keep updating this thing. If I have multiple instances of my worker role, I can also configure Wasabi to go ahead and use blob leasing to control execution so that only one instance of this role is going to be able to do the work at any time. And then that worker role could call the service management API to then update our configuration for our cloud services. So again, our service information file is going to contain information about our Windows Azure environment, the various subscription, management information, all that sort of stuff. There's also a really nice stabilizer that's here. It's basically one line of XML code we have to write. And the nice part about this is it helps us to really control when we want to scale and how fast we should scale. I can control the hour that I want to scale up or down. For example, if I only want to scale up my instances on the first 10 minutes of the hour and scale down on the last 15 minutes, this is nice for us because we know that with Windows Azure, I get charged per hour whether I'm using the full hour or not, and I get charged per clock hour. So I want my scaling decisions to happen at the beginning of the hour so that I'm really getting as much utilization of that role for the entire hour that I'm being charged for it. Then when I want to scale down, I want to scale down maybe 10 minutes before the end of the hour so that I'm sure that that instance is torn down before the start of the next clock hour. And we have the stabilizer also gives us the ability to have cooldown periods, which is what we talked about before, where I don't want to scale and up and down, really have this yo-yo effect. I want to make a scaling decision, and then maybe I want to wait for 20 minutes to see how the system reacts, and then I'll make another scaling decision. So you see here's an example of our service information file, where I list out my subscription, I list out the different cloud services that I have. You notice that there's a scaling mode here that I set to scale and notify, which means that anytime a scaling decision happens, I also wanted to send an email to me, which I think is kind of nice. What are the roles in that particular cloud service that we're going to take some action on? Storage account, we define that so I know what Windows Azure storage queue to work with. And then the stabilizer, to set that up, is basically one line of XML here. You just add that stabilizer element and put in the times that you want it to work with. So pretty easy there. There's two types of rules we have with Wasabi as well. There's constraint rules and reactive rules. And constraint rules are basically your predictive type of rules. There's things if I know that a certain event is going to happen a certain time frame, I can associate that as a constraint rule. I'd also use a constraint rule as a guard condition, basically telling me I want no less than a certain number and no more than a certain number. Basically give me a ceiling to control my cost. I always want to make sure I have at least one of these constraint rules in place. Really is that bound of the system, because what could happen is without that bound, I could have reactive rules. I could try to maybe constantly keep adding more number of instances, and I don't want to do that. I want to stop at a certain ceiling. Reactive rules are pretty much what they sound. They react to certain conditions, certain metrics that you're monitoring, and then I can adjust the number of instances there. So I have a condition here called an operand that basically is a metric that we're using to kind of watch. So maybe it's performance counters, Windows Azure storage queues, or my own custom ones like a service bus queue depth or number of records in a particular SQL database table. I then have actions, and the default action is a scale action. That's just going to say I want to scale up or down the number of instances. And if I wanted, I can create my own custom action as well to maybe send emails execute a database script, something like that. Be a custom action that I can extend and apply to our Wasabi block here. And it's important to note that all these rules, constraint rules and reactive rules, have a rank. The highest rank wins. So if I have maybe some conflict on who should take precedence, this ranking system does apply. Constraint rules will always override reactive rules, which is basically helping us to ensure that our guard condition that we deployed, we don't ever constantly exceed maybe that upper or lower bound. So we look at our rules here. We can see we have a guard rule in place that says, hey, I want no more than 5 and no less than 2 instances of this rule. And then I know that Monday through Friday from 7 a.m. to 7 p.m. is going to be when I'm going to be busiest. So I specify that in the timetable here and say, hey, go ahead and scale this MVC web role up to 4 instances during this period of time. I can have reactive rules that will increase or decrease the number of instances in my web role as well. So I say, I want to increase by 1 whenever the queue length is greater than 10 for an average of 5 minutes. And I also want to make sure I have a compensating rule as well to scale that back down. So I have the orders decrease rule here that will say, hey, anytime that the queue length for 5 minutes is less than 10, I want you to scale down. So it's a -1 to scale down the number of instances. And then at the bottom there we see our operand that basically is doing a time span for 5 minutes, doing an average on the number of messages in that orders queue. I can also configure Wasabi to send me notifications. So I specify either a notify or scale and notify in our configuration file. And then on our regular app config file, I just use normal .NET configuration here for our system.NET mail settings, specifying that, maybe using a SendGrid, for example, as a Windows Azure partner to send out emails for us. I can also have Wasabi track these requests, any sort of management operations against the API, putting a message in a queue. That way maybe I would have another role instance or another process somewhere that could pull messages off this request tracker queue. And then I could be able to use that to kind of see what's going on with the operation. I get some parameters here that tell me my subscription, what the request ID was, and so forth there. So nice information to kind of see what's going on. Let's take a look a little bit at the code here for this. We'll go back over to Visual Studio here. And let's look at, here we have a service scaler cloud service, and it's all just using the service scaler worker role here. If we look at the code for this guy, you see here there's really not a whole lot of code that we have to write. I create an instance of this auto scaler. The run method is a standard, in this case a standard one right out of the template in Visual Studio. And then in the on start, all I'm doing is getting an instance of that auto scaler using the enterprise library configuration and starting that up. I want to make sure that I do tap into the stop method for this worker role as well. I want to make sure that I do stop this scaler. When this role stops, I want to make sure that I clean up the leases on the blobs that I'm using, because I've turned on the ability to lock or release blobs here, so I have only one instance of getting access to do the work. If we look at our app config here, I'm going to open up the using the enterprise library configuration tool to open up this app config and show some of the stuff that's available there. So take a look in here. Let's expand this a little bit so you kind of see what's going on. If we drop these down, expand these, you can see here these are nice ways we can go in and really update, like, where are my different rules stored. So I kind of see they're stored, where's the XML file. I can monitor these every 30 seconds for changes. Same thing with the service information. Where is that stored in blob storage account details, monitoring information there. This is where I can configure the request tracker, so I want that to happen. And also with blob leasing, do I want that to be enabled as well? And I can configure that here. So this makes working with the API and working with the configuration a lot easier. I can make my changes there, save that, and we're ready to go. Then I can just deploy this worker role out to Windows Azure, and we'll be set. So this is kind of recap. We can create a new worker role to host Wasabi. Is probably the most common way. We'll use the enterprise library configuration tool to add all the necessary base configuration in our app config. Then we'll add all of our rules and our service information to 2 XML files, put those into a Windows Azure blob container, and then deploy this entire role. So pretty easy to get set up on that. You'll probably spend most of your time working with your rules and service information configuration files. Some things you might run into, a couple of hiccups I've noticed with working with Wasabi. It is an older library. It was built against an older version of the Windows Azure Storage Client library. So you'll get an error that says it couldn't find that assembly. If you're using a newer SDK, you want to do a binding redirect to make it use the 1.7 version of the storage client library. You also need to make sure that when you deploy Wasabi, you have your management key in Windows Azure, the management cert, but I also need to deploy the private key certificate along with this role. So I'm going to create a service certificate as well and deploy that along with my worker role. If you're using OS Family 3, which is functionally Windows Server 2012, the Windows Azure account that's used to run your worker role runs under network service, which does not have permissions to actually get information out of the local certificate store. So you'll need to change the execution context on your role to elevated, which basically tells this role to run as an admin so that it can go ahead and get those certificates out of the local certificate store. Some helpful resources here. Definitely be sure to check out the different blogs and articles here. They're great resources, have some great walkthroughs. The first one there is basically a 6-part series on using Wasabi, a great resource there. And there's some labs and developer guides as well if you want to learn more about the Windows Azure Auto Scaling block. So to kind of wrap up, I think you've hopefully seen that the management API is not that difficult to use. And once you get the basic get and post operations in place, basically it becomes an XML exercise at that point in creating and parsing XML. If you want a little bit easier way to go, I definitely recommend checking out the Azure Fluent Management Library. Get that, and you can see it's a very few lines of code to write and gives you, you can really focus on solving your business problem, not parsing XML. And we have the Windows Azure Auto Scaling block, or Wasabi, we can add to our solution, which really handles all those kind of complexities and intricacies in how we want to scale our Windows Azure solutions. It becomes basically a matter of setting up the correct configuration for our subscription and the different services we want to go ahead and monitor. So if you don't already have Windows Azure, I definitely encourage you to take advantage of either your MSDN or BizSpark or Partner Network or Website Spark benefits. You can get up to $6,500 in Windows Azure benefits there. Or if you want to go ahead and sign up for an Azure trial, you get a free 90-day trial as well. With that, I'm going to wrap up. Say thank you for attending AzureConf. Definitely feel free to hit me up on Twitter, tag your questions with #AzureConf. I'll definitely try to respond to those as well. And thank you.